This video is a review of fat digestion and absorption and some key takeaways that you need to know for this process. So this image is from your book, and it's looking at digestion and absorption of fats. And starting here, we just want to mention that really nothing is happening in the mouth of digestion and absorption, and little is happening in the stomach. The real place of action is in the small intestine. And I'm going to show you this from the next slide, which I think depicts it a little bit better, what's happening in the small intestine. So this image is also from your book. And what you can see is that when we consume some type of lipid, in this case, we're looking at triglycerides. We consume triglycerides. Remember that fat and water don't like to mix, and the enzymes that are going to help break those fatty acids off of the glycerol backbone, they actually are in the watery substance. And because fat doesn't like to go in water, we need to have something that can get those triglycerides into the watery substance so the enzymes can clip off the fatty acids from that carbon backbone or that glycerol backbone. So as you likely recall from the book, that there is a substance called bile. And bile acts as an emulsifier. It has an end that likes water and an end that likes fat. And so it allows these two to interact with one another. Encourage you to watch the McGraw-Hill video that talks more about emulsification if you have questions on that particular process and how that happens. So needless to say, here we have triglycerides. Bile acids come in from the gallbladder. Remember, they're produced in the liver, sent to the gallbladder, and then from the gallbladder into the small intestine. Bile is released there. It emulsifies fat, which then allows the enzymes to work, and the enzymes will break off the fatty acid chains from that glycerol backbone, so you'll have free glycerol. You'll also have, sometimes it will just cleave off two or cut off two of the fatty acids, so you'll have the glycerol backbone to the 3 carbons, and then to one of those carbons you'll still have a fatty acid tail linked, and that would be a monoglyceride. So monoglycerides and our fatty acids can be absorbed to the small intestinal cell as well as glycerol. And when we think about the fatty acids, the chain length really determines where it goes. So you can see in this chart, if you have a short or medium chain fatty acids, so between up to 10 to 12 carbons chain, then they're actually just going to be absorbed in the small intestine, go directly to the blood, and then go to the liver. So they'll go to the portal vein and then to the liver. However, if you have long chain fatty acids, so those could be maybe 16, 18 or longer fatty acids or carbon units linked together, then it's going to go through a different process. In fact, it has to be repackaged in the small intestinal cell into a triglyceride. So I know it kind of maybe seems strange that we had it in a triglyceride form, we break it down to its smallest units, and then we build it back up. That's kind of how the human body works. In order to get it across cell membranes, we often have to break it down into smaller pieces, and then we can get it across, and then we build it back up. So in this case, that's what we're doing. We're taking long-chain fatty acids and putting them back into triglyceride, and then we're packaging them with cholesterol and protein, phospholipids to create a lipoprotein called a chylomicron. This chylomicron then is transported through the lymphatic system first, and then it goes to the cardiovascular system and then to the liver. So sometimes I know students have had questions about what's the lymphatic system. So I want to remind you from Chapter 3, we didn't go over this in great detail. This wasn't part of one of the study guide objectives, but I'll just bring it out here. This is really FYI, so you can have some context around these two systems. So most of you probably are familiar with the cardiovascular system, thinking about how blood is transported, blood and oxygen are transported throughout the body. And it's the vasculature is throughout all of our limbs, everywhere in the body to be able to maintain health of cells. Well, the lymphatic system really is for immunity. So when you think about anything with lymph or lymph nodes or white blood cells or anything that's there to fight infection or anything we need from to remove foreign substances, or just thinking about overall immunity, think about the lymphatic system. But it also is involved in fat transport, as you just learned. So through a chylomicron, it's transported, the chylomicron is transported in the lymphatic system. And really, this gives a nice summary from your book. If you do have more questions about fat digestion absorption or any of the body systems here, feel free to reach out to me or to the TAs.